In this video, we're going to talk about linear pairs. And so before we talk about a particular example, let's make sure we understand how degrees work with lines. So what we're going to do is we're going to call this piece right here our initial side. And so that's going to be where we start. And so we'll call that 0 degrees. And then we're going to rotate around. Well, when we're talking about rotation, saying that word a little weird, what we're really talking about is kind of a circular thing. So angles kind of work in a circular manner. Let's go ahead and take a look at this particular circle with relation to this line. So if we start here at 0 degrees and make our way all the way around, that's a circle, so that would be 360 degrees. Okay, so one full revolution is 360 degrees. So that means halfway around over to here must be half of that. Well, that's 180 degrees. And so that's where we get this idea that in a line, there's actually 180 degrees. All right, so let's go ahead and get rid of that for right now. Let's go ahead and, again, just kind of illustrate the fact here that if we were to travel halfway around, then we're just going to be traveling 180 degrees. And that's a good thing to know, because if we then, let's say, add in a piece here, and we know that this section right here is equal to 4x minus 12 plus 12, and that the other piece here is equal to 3x minus 1, then we can kind of start using that whole versus part thing. If I take this orange piece here, 3x minus 1, and I add the green piece here, 4x plus 12, they form a linear pair or a linear angle, and we know that a line, one side of this line, is a semicircle, so it contains 180 degrees. So if we add those up, we get 180 degrees. And from here, we can go through and combine like terms and solve. And we get down to here, and then we find that if 1x is equal to 169 divided by 7 degrees, which is approximately 24.14 degrees, then the orange angle plus the green angle will add up to form a linear pair of 180 degrees. Now, one of the things I want to point out with this is if you make a mistake here, it's likely you're going to make a reasonably large mistake, especially if you show your work and you're kind of looking through those steps and they make sense. So what we could do to check our answer is we could plug this value in. Again, we'd want to plug in our exact value, not our approximation, into our equation here and see if those two add up to 180 degrees. I'm going to suggest something slightly different though. What I'm going to do is I'm going to say this is pretty close to 25. So I'm going to bump it up a little bit to make the arithmetic easy. And then I'm going to go ahead and say this is approximately 4 times 25, which is 100. So 112. And again, that's going to be a little big. And this is going to be approximately 75 minus 1, or 74. And then if I take 112 and add 74 to it, I'm going to get 186. Now, is that 180? No, but is it pretty close to 180? Yeah, so I at least know my answers in the ballpark. And so if you're really like, oh, Mr. Cooley, I don't want to, plug things into this and check my solution exactly, well, you can just check it approximately using values that are a little easier to multiply, and then at least you'll know if you had the right idea or if you really messed up somewhere. Now, again, if it's important, if it's an exam or you're doing this for a project and you really need it to be right, I would go for the exact answer. But, I'll be honest, I do this all the time. Is my answer in the ballpark? It is. And so this seems reasonable, and we can go ahead and stop there. I did verify it off camera, so we can feel confident that this is in fact correct.